Okay, guys, so we're here. We might as well do something. So let's do some trig, just to keep sharp. And trig is really important for grade 11. You do a huge amount of trig in grade 11. So let's make sure you've got those basics under the belt when it comes to your trigonometry. Are you excited for grade 11?
Yeah.
It's going to be so big when you're in grade 11.
They say that grade 11 is the hardest grade out of all the 12 grades. Is that true?
I think it's true. I think it is true.
Not at all excited. How come, Siamo?
Well, but you guys have to it's quite a big step up from grade 10, I think. And you also have to, I mean, with grade 11 results, you start applying for varsity. It's just all happening from here on. It's gonna happen so fast.
Yeah. Your final marks are very important for university applications.
Yeah.
Yeah.
It's like here you are in grade 11 having to decide the rest of your life. No, I'm joking. I'm joking. You don't have to decide the rest of your life in grade 11.
Yeah.
Gosh, if I decided
that, you'll be fine.
What did you think you were going to be in grade 11, Miss Nelly?
I was going to be a doctor.
Me too.
Yeah, that's what I thought.
Me too. Now we're teachers. Look at us.
Yeah. We are teaching doctors, so we're so aligned to that dream. So yeah.
You know what happened, Emmanuel? I got into medicine. I got accepted, and then I thought, no, this is going to take too long. And then I switched from medicine to business. And I don't know why I thought that was a good idea, because it wasn't. So I did a 4-year business degree, and then I went and worked in business, and I hated it. I absolutely hated it. And then I became a teacher, and so I did the 4-year business degree, and then another like 5 years with my master's for education. So I ended up studying longer than a doctor. So it was silly. But it's okay, it all worked out very well. So I don't think in the end I would have made a good doctor. I think I would have run away from the blood. I would have chosen something like
that's the thing for me. It's like wounds, blood. I don't like those things. Like stay away from those things.
It's nasty. Yeah. I think I would have chosen like a bloodless specialization, like dermatology or maybe plastic surgery. No.
Yeah.
Okay, so write down when you're in grade 11 what it is you want to be, and then talk to yourself again in 10 years' time and have a little laugh.
Yeah.
But you are going to be a doctor now, Miss Neliswa, just not a doctor of medicine. You're going to be a different. Miss Neliswa's going to do her doctorate next year.
Yeah.
Sorry, I forget what it was. What was it in?
It's going to be like in engineering, but it's like research. So it's not going to be specified to like civil engineering or but it's under the School of Civil and Environmental Engineering. I did environmental science, so and then for my master's I did engineering, like environmental engineering. Yeah. That's
so cool. And that's what I'd actually tell you guys. Like, don't go for the usual stuff. Go look for something interesting, like something different. Like, just go do something different. Like Miss Neliswa, who's going to be a doctor in engineering.
Hopefully in 3 years.
Oh yeah, let's talk about that as well, how long it takes to do a doctorate. 3 years plus 2 divided by 9.
Yeah. No, 3.
Okay, so back to trigonometry. None of us are getting anywhere with our trigonometry. So let's do this first one. If x is 37 and y is 44, calculate the value of that expression. So this is just calculator work, okay? So you can just put that into your calculator, and when you have an answer, put it in the chat, please, everyone. It's almost quick.
Wow, that was quick.
Yes, you must round it off to 2 decimal places. Because okay, I think you must check your work there, Siamu. I get a different answer. Let's see what Robin Lee and Emmanuel get. Yes, Emmanuel, I also get 1.8. So remember to do the sine squared. You go on your calculator, sine 37 squared plus 2 cos 44. So just check your calculation there, Sioma, but it should be 1.8. Right, so 3.2. Now you can't use a calculator. You have to use 32. That's okay. That's just a little slip. So we need our special angle triangles for this one, 60 and 30, and then the other one is 45 and 45, and that's 1 root 2, and this is root 3 and 1 and 2. Yes, okay, and we're going to use that to work out this monster here. Well, tiny monster, it's not a big monster. Okay, when you have an answer, put it in the chat. Hi, Vatsilo. Welcome. We're doing a bit of trigonometry because for grade 11, trigonometry is super important. You do a lot of trigonometry in grade 11. Munete, hi, Munete. So we're doing 3.2. I think we have about a minute left, but you can settle in and then maybe just follow for this first question for 3.2. Okay, so let's start with sine of 30. So sine of 30. What is that face? Why is that face there, Tsiamu? I don't know. What is going on? What is the shock about? Do you need more time? Okay, it might be odd. There's some odd stuff here. So sine of 30 is opposite over hypotenuse, so that's 1 over 2. And then cot 45, cot is the inverse of tan. So instead of going opposite over adjacent, you go adjacent over opposite. So adjacent over opposite, that's still just going to be 1 because it's 1 over 1. And then cos of 30 is adjacent over hypotenuse. So that's root 3 over 2. And then tan of 60. Tan of 60 is opposite. I've lost my train of thought. Opposite over adjacent tan of 60. Yeah, it's root 3. Did I do that right, Miss Nelly?
Yes.
Tan of 60. Okay. Right, so we've got a half times 1 at the top. And that's just a half. And then we have root 3 over 2 times root 3 over 1. So we're going to times root 3 and root 3 together. That gives me 3. And then 2 and 1 together. That gives me 2. So I have a half divided by 3 over 2, which is the same as a half times 2 over 3. So you do your tip and times thingy there. And that's going to give you a third as your answer. So I hope that was your odd answer that you got, Tiamu. But yeah, did anyone get a third? Any success with that one? A third? No one? Just tell me. Oh, Robin Lee got it. Okay. Everyone else? Manuel? Chilo Mineta, no, you guys came a bit late, maybe. Okay, so you forgot to simplify. Okay, so did you get up to a half over 3 over 2? Okay, yeah, so make sure that you go all the way with that one. All right, so that's special angles. Tick. Special angles never leave you from now till the end of matric. These little triangles will be part of your existence. And these stacked fractions, I call them stacked fractions. I don't know if that's the right word for them, but that's also going to be with you when you do these kinds of sums, because you just always have to substitute in these values for the 30, the 60, and the 45. Okay, next question. We have triangle ACD is right angled at C, and E lies on AD such that CE is perpendicular to AD. Write down the ratio for cos D in triangle ACD, etc. Okay, so I'm going to give you some time to do this one up to here where it's 3.3.3. And then yeah, let's do 3 minutes. I think it's fairly quick to do this one, so we can check back at about 20 past. It's just gone 17 minutes past, so 3 minutes, and then we'll check back what your answers are. Okay. I've put the first answer up for cos of angle D in triangle ACD. So that's the big triangle. So that's DC. It's adjacent over hypotenuse, so DC over AD. And then you have to look in the small triangle, CED. So that would be adjacent is ED, over hypotenuse is DC. And then if AD is 13 units and DC is 5 units, so AD is 13, DC is 5, calculate the length of ED. Okay, does anyone have that answer? AD is 13 and DC is 5. What is the length? How did you get 12 units, Chilo? Trying to figure this out. AD is 13. So we can do Pythagoras to get AC. If we do Pythagoras for AC, then we can go 13 squared. Was there a quicker way? 13, it's only 2 marks, so there must be a quicker way. Minus 5 squared. Yeah, so AC is 12. This one here is 12. But do we know if AD is 13 and DC is 5? Length of ED. So we just need this little bit here. I get 12 too, but I get 12 for AC. So ED can't be 12. Unless we work out this angle using even this angle. Yes, it's quite a lot of work for 2 marks. Because if we use trigonometry to work out angle D, 90 degrees in ECD, yeah, but we still only have that one side. We need the small, yeah, so if we use DC, but we would first need to figure out what angle D is. Yeah, we're basically going to use what we just did here. Okay. Seems a lot of work for 2 marks, but anyway, let's give it a go. So cos of angle D, we worked out in the big triangle, ADC, is 13 over 5. No, 5 over 13. That means we can tell what angle D is. So angle D is shift cos 5 over 13. And that gives me 67,38. And since I have a side and an angle, I can now use that side and angle and trigonometry to calculate ED. Now, ED is over here. We already made a ratio for cos of D in the small triangle. So in the small triangle, we can say cos of 67,38 is equal to ED over DC, which is 5. And then we times by 5 and we get ED. So 5 times cos 67.38 gives me 1,92. Okay, so just be careful when you work out sides. Be like careful about what you're actually working out. So if you worked out the 12, you actually worked out AC. we didn't have enough information to just work out ED using sides. We had to use our trigonometry to find the angle first. All right, let's go to 3.4. And we've got, given that cos theta is 5/13 and sine theta is smaller than 0, with the aid of a diagram and without using a calculator, determine the value of those things. Okay. So what do we need to do here? Question tells us what we need to do. We need to draw a diagram. So Cartesian plane diagram, you'll always have one like this in grade 11 as well. There'll always be a Cartesian plane diagram question that you have to answer. So it says cos of theta is 5/13 and sine theta is smaller than 0. Okay, so we need to determine the quadrant in which we are going to draw. So if cos of theta is positive and sine is negative, you're right for Chilu, nice one. We are going to draw here in the fourth quadrant. Okay, so when we are doing cos, we have our adjacent side and our hypotenuse side. So this is going to be my angle, theta. And our adjacent side is going to be 5. So that's also, you can think of it as x over r. So that's 5, and this is 13. And this is going to be minus y. Okay. Work out what y is, and then tell me in the chat when you get an answer, what is your value for y? Okay, so you have to draw where cos is positive and sine is negative. Yeah, so we know that cos is positive in the first and the fourth quadrant. But the other criteria that needs to be there is that sine is negative, and sine is not negative. Sine is negative in the third and the fourth. So because sine is negative and cos is positive in the fourth, that's where we're going to draw. So you use the information here that's given to know where it has to go. Well, it would make sense if it's minus 12. I think you're right, Wichilu, because look, in the previous diagram, we had those same numbers, and that was 5 and 13, and the missing side was 12. So I think you did on. Y is equal to minus 12. So you just do a Python calculation for that. Okay, and now we're going to do sine theta. Well, you're going to do sine theta. I've done the work with the sketch. So it's up to you now to do 3.4.1 and then 3.4.2. We can do them one by one. So let's do sine theta first. Put your answer in the chat for sine theta. Now you use your diagram, right? You make a ratio for sine theta using your diagram. Pop it in the chat when you have it. Can we just doing opposite over hypotenuse? We've worked out the missing side already, so it's all there. Tsioma, because this says without a calculator, you must never give decimal answers. Okay, so you're just gonna make a fraction. So just write your answer as a normal fraction. Opposite over hypotenuse, come, who's got an answer? It should take 2 seconds to do. Let's go, everyone else. Where's everyone else? Okay, so you work with this angle. So that's opposite over hypotenuse. You always work with the acute angle. Don't forget your signs. We are looking at y on the negative side, so it must be negative 12 over 13. Negative 12 over 13. Okay, next one should take a little bit longer, but not that long. Sec theta plus tan squared theta plus 1. Yes, it's those little mistakes that you guys must watch out for. Okay, let's do this one. As soon as you have an answer, pop it in the chat, and remember, no calculator. You cannot touch a calculator in this question. Sec theta plus tan squared theta plus 1. Remember, sec is the reciprocal of cos. So if you know that sec is the reciprocal of cos, you can just take cos of theta, which we said was 5 over 13, and swap that around, make it 13 over 5. And then you do tan of theta plus 1, or tan squared theta plus 1. So tan is opposite over adjacent, so that's negative 12 over 5 squared plus 1. Manual says 234 over 25. Okay, so that's 13 over 5 plus 144 over 25 plus, I'm going to change this 1 straight away to a 25 over 25. No calculator, we're back to doing grade 7 fractions here. So 5, to make the denominators the same, we have to make this 25. And then 13 times 5 is 65. I hope. 13, yes, because 12 times 5 is 60, so 13 times 5 is 65. And then that's 144 and 25 over 25. And you're going to add all of that up, and that's when you could possibly sneak in a little bit of a calculator. And I also get what you guys got, 234 over 25. Well done, 234 over 25. Excellent. Sometimes those weird answers are correct. Sometimes they're also not. So okay, I think that's that for the trig section. We've got trig graphs next. Okay. Who loves trig graphs? Okay, have a look at the question. Become one with the question. This is going to be our last one before we call it for the year. I think we've deserved a break. All of us.
All of us, we do. It's been a long year.
Oh, Emmanuel says it's his favorite, but Sheila says it's his worst. Okay, I'm gonna give it about 3 minutes so that you can interpret the question, have a look at it, what's going on, attempt those questions up to 5.1.3, and then we'll go over it. We are calling it for the year. That is it. Well, not in about 10 minutes it will be.
We need
Sure. How many lessons?
Rooster.
Hey?
We need Ayanda's rooster in the background to college from the previous class. We're like, this is the final.
No, Chilo, stay with us. Stay with us. Yes, the rooster pretty much rang in the end.
Yeah.
In our previous class, somebody has a rooster, and as we were ending the lesson, the rooster just gave a huge crow. It was actually quite cool.
Yeah, it was.
I want a rooster. No, I actually don't want a rooster. I want hens. I don't want a rooster.
But you want one to wake you up in the morning.
Yeah, but they wake up at like 4:30.
Yeah.
It's a lot. Okay, 1 more minute. I can just see how everyone's answering these questions, knows exactly what's going on with the trig graphs. They can remember it. Oh, this wasn't in your exam, Buchino. It will be next year.
Definitely. Even in metric as well.
Okay, so let's look what's going on here. We have f of x is 2 cos x. So we've got a cos graph. And g of x is sine x minus 1. So we've got a cos graph and a sine graph. You can tell which is which by the shape, but also it's indicated for you by the f and the g. So the cos graph has a 2 in front of it, which means it has been made higher. The amplitude has increased. The normal amplitude of a cos graph is just a 1, but in this case it's 2, so our graph has gone higher, and you can tell here as well by the 2 on the y-axis, and then our lowest point here is minus 2 on the y-axis. Okay, so I'm going to make our cos graph purple, and I'm going to make our sine graph orange. And how have we shifted our sine graph? We have moved it 1 unit down. So it's literally like taking it, picking it up and taking it and putting it 1 unit down on the y-axis. Okay. So don't get confused with the making it go higher, like stretching it. It's like waves that go bigger or higher. It's like a tsunami, a higher wave, as opposed to just moving things up and down on the Cartesian plane. So both of these graphs, you should know, has a period of 360 degrees. And what is a period? It is the amount of degrees, if you remember, that it takes for the graph to make one of its signature patterns. So a signature pattern for a cos graph is that, if you remember. And for a sine graph, it's like a roller coaster, basically. So that's a signature pattern. So on a normal cos graph, it's 360 for one of those patterns, and the same for a sine graph. Now you can change that period, but that is something you only do in grade 11. In grade 10, you don't do period changes. Okay, so you can just get one easy mark here because the period is the period and it's 360 degrees. The only one that's the odd one out is the tan graph. It's 180 degrees for the period. Now the range of G is the lowest y value to the highest y value. So you go literally on your graph and you look for the lowest y value, and that's going to be here at -2. And the highest y value is over here at 0. So it dips down to -2, and the highest point it goes to on the y-axis is 0. So we have to write an inequality for that. So it's between -2, and it can also equal -2 and 0. And then you could add like y is a real number. And then it asks for the number of solutions to f of x equal to g of x in this interval. The interval is 0 to 270. So you can see the graph starts here at 0, and it's like a snapshot of the graph. We're just looking at it between 0 and 270 degrees. This goes on forever. We're just looking at it like it's looking at it through a window and just seeing this graph come past, and this is all we see. Okay, and we see the sine graph comes past, and this is what we see. So we see they cross each other. That's what it means when they are equal, where they cross, and they cross each other twice. So the number of solutions to f of x equal to g of x, blah, 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 in this interval just means how many times do they cross? And they cross twice. Okay. So it's basically like just translating the maths language into real language. And when you do that, you realize actually not that complicated. Okay, so 5.2, let's see for which values of x in the interval. So we now know it's just this interval. It looks complicated, x between 0 and 270. It's not, it's just for this interval. Is f of x times g of x greater than or equal to 0? Now, this just means if I take the y values of f of x is the cos graph and g of x is the sine graph. So if I take those y values and multiply them together, I need to get a value greater than or equal to 0. Now we know to get greater than or equal to 0 means positive. So first of all, let's translate that. Greater than or equal to 0 means positive. And we know from our maths that a minus times a minus gives me a positive, and a plus times a plus also gives me a positive. So we basically have to look where the two graphs are both negative, both have negative y values, and both have positive y values, because if you multiply those y values together, you'll get a positive, and that's what you're looking for greater than or equal to 0. So where does that happen? So we literally start to look. I wonder if my ruler works. Yes, it does. Can I switch it around? In the last lesson, I discovered the ruler. But I don't know if I can make it work. Okay, no. Let's leave it over there. Okay, so if we read from left to right, so we basically start walking from the side. And if we look at the y values here, it's positive. But the y values for the sine graph are negative. So when we multiply positive and negative, we get negative. So that's what we're going to get here. So that's not going to be a solution for us. We're looking where it's positive. Okay. So over here, the sine graph goes negative. It dips down below the x-axis. So the sine graph is negative. And guess what? The cos graph is also negative. Negative, 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 negative the whole way. And for which interval does that happen? By the way, because they're both negative, you're going to get a positive if you multiply their values together. Whatever those values are, we're just talking in general. So it's actually from here, from 90 degrees up to 270 degrees. That's going to be our solution. So we write that as an inequality. So 90 is our first one. Can it equal 90? Yes. And then it can also equal 270. So that's going to be our answer for that one. Okay. You'll always get these graph interpretation questions. So just really practice them, get used to them. But the more you practice them, and you just really need to learn what those things mean, because they can only ask multiply together gives you positive, multiply together, get negative, and then divide to get positive or negative. The questions are all the same. It's there's a limited number of questions that can be asked for this. Okay,